In section 12.2, we were playing simultaneous games that only happen once, but there are plenty of situations, including in the goalkeeper penalty kick game, where um, that might happen many times. So we have to pivot to repeated games. In this case, we're going to look at finitely repeated games, so games that only happen a finite number of times, not infinitely many times. When a simultaneous game is played repeatedly, strategies are temporal, consisting of a strategy for each period. To analyze these games, we have to use backwards induction. This involves solving a multi step game by first solving the last step and then working backwards. Again, consider the prisoner's dilemma that arises when Disney and Warner Brothers decide whether or not to advertise. Imagine that they have two movies. The two each plan to release Lego and Frozen movies in the first period. Total payoffs are maximized when both firms decide not to advertise, just like in the example earlier in the chapter. So the question then is, can the prisoner's dilemma be avoided in two periods? If firms know how many periods there will be, without some sort of commitment device, without some sort of thing to guarantee that their opponent will commit to their strategy, they'll both have the incentive to cheat in the period prior to the last period. What about infinitely repeated games? You would expect that most markets would be, at least when you're determining strategy, infinitely repeated. No firm plans to stop existing at some point in the future. The Apple and Samsung case would be like this. Apple and Samsung probably make decisions assuming that they will continue to compete against each other for infinite periods, infinite years going forward. Of course, they probably won't last infinitely, but that's how they likely make their strategic decisions. So in infinitely repeated games, sometimes you can sustain cooperation, but this makes it very difficult to analyze. Rather than attempting to determine the optimal strategy for Disney and Warner Brothers, consider a specific strategy and then decide whether or not that specific strategy constitutes a Nash equilibrium. So assume that the two companies plan to release Lego and Frozen movies indefinitely. Every year, a new Lego movie comes out, and every year, a new Frozen movie comes out. One possible strategy would be for Warner Brothers to not advertise in the first period and continue to not advertise as long as Disney also does not advertise. However, if Disney advertises, then Warner Brothers will start advertising and continue to do so forever. Disney does the same in turn. So to determine whether or not this constitutes a Nash equilibrium, we have to evaluate whether either firm can do better by defecting. So sort of underlying this analysis has been the assumption that if either Warner Brothers or Disney cheats by advertising, both firms will advertise from that point going forward. Economists refer to this as a grim trigger strategy. Cooperative play ends as soon as one player cheats. An alternative strategy is tit for tat. This is when a player mimics his opponent's strategy from the previous period. So the player cheats if his opponent has cheated in the previous period, and cooperates if his opponent has cooperated in the previous period. Uh, you can see pretty quickly how these infinitely repeated games end up with very complicated equilibriums.